Hello everyone, this is Dr.M.Nookaraju, Associate Professor, Department of Chemistry, Aditya University. Today we are going to discuss about secondary batteries. So at the end of this lecture, what you will gain is you can know the construction and working of nickel cadmium battery, and you can also know the construction and working of lithium ion battery. So let us move to the concept of secondary batteries. As in the previous lecture, we have discussed about storage devices. What is the electrochemical storage device? Is a battery where we can have the conversion of chemical energy to the electrical energy and vice versa. As we have discussed in the primary batteries have a disadvantage that we can use only once, we cannot recharge them. That is why in present era we are having portable devices like mobile phones, laptops, electrical vehicles, where we have a rechargeable battery, so that we can have charging and discharging cycles. So today we are going to discuss about the batteries we use in portable electronic devices and inverters. So a battery is a device where the chemical energy can be converted to electrical energy. So we are going to discuss about secondary battery. A secondary battery is a rechargeable battery where the energy stored in the device is recharged and reused for multiple times. So we can convert or change the connections so that we can have the internal electrochemical reactions that are reversible in nature. So we can have an external circuit so that we can have the reversibility of the reaction. So unlike the primary batteries, we can have the reversible reactions. So spontaneous electrochemical reactions are being reversible. So we are going to have sustainability for the applications in portable devices like smartphones, laptops and electronic vehicles. So they are having a characteristic of reusability and the rechargeability. This is the advantage of secondary battery. So the best example is the inverter battery we are going to use is a lead acid battery and nickel cadmium battery that we are going to use in the digital cameras, and lithium ion batteries. No doubt everyone know about it, as we are using lithium ion batteries in our smartphones, laptops and iPods. So first we will move on to the nickel cadmium battery. What is a nickel cadmium battery? It is a type of alkaline storage battery. Why we call it as alkaline storage battery is we are going to use an electrolyte made up of potassium hydroxide, an alkaline solution. That is why it is a alkaline category battery. So it is a portable rechargeable battery, and it is going to give a fairly constant of about 1.4 volts. So what are the major components of this battery is we are going to have a anode made up of cadmium, cathode which is of nickel oxide, and an electrolyte of a solution of KOH. That means we are going to have an anode made up of cadmium, cathode and the electrolyte combination, so that we can have the construction that is completed. So the electrode and electrolytes are enclosed in a sealed container. So we can represent it as a conventional galvanic cell, where we are going to, how we are going to represent conventional galvanic cell is we are going to write the anodic part first. What is this anode? Is cadmium. What it is going to do is it is going to be converted to cadmium 2+. Then we are going to write the cathodic part, where the nickel hydroxide or nickel oxide can be changed to nickel. Like this we are going to represent this. So representation we are going to do as cadmium hydroxide, and we are going to have an electrolyte KOH, then nickel oxide by nickel. Like this we are going to have the representation. So a schematic representation of the nickel cadmium battery that we are going to use is like this. So nickel cadmium battery having a potential of 1.2 volts and a power efficiency of 600 mAh is being represented here. We can recycle or dispose. So what are the reactions, how it is going to work is we are going to have two cycles, one is discharging and other is charging. So during the discharging what will happen is we are going to have the chemical energy that is being stored, that has been converted to electrical energy in the form of galvanic cell. So the NiCad battery operates when cadmium is oxidized to cadmium 2+ ions, and these cadmium 2+ ions are being reacted to the OH- ions of the electrolyte to form cadmium hydroxide. It is the anodic reaction which is a oxidation. Then Na2 plus ions then combine with the OH minus ions to give NiOH twice, which is the reduction reaction. So at cathode, cadmium is being oxidized to cadmium 2 plus. At anode, cadmium is oxidized to cadmium 2 plus, and at cathode, nickel oxide gains the electrons to give the nickel hydroxide. Like this, we are going to have a simultaneous reaction, a redox reaction. So this is the oxidation part or the oxidation half that is going to take place, whereas the reduction half at cathode is like this. So what is the overall reaction we can write is CD cadmium react with nickel oxide in presence of hydroxide, so that we are going to have cadmium hydroxide and the nickel hydroxide as the product. So this is the overall reaction that is going to take place during the discharging process. Then what happened during the charging? What is charging? Is reversible to that of the discharging process. So what we are going to do in the charging process is we are going to connect it to a external source. At positive terminal and negative terminal, we are going to have the electric energy that is being supplied. So that electrical energy will convert to chemical energy. So during the charging process, what happened is it is going to work as an electrolytic cell. So the cell can be recharged by passing excess current. That means we are going to give around 5 volts or 6 volts voltage from our external cable. So in the opposite direction to that of the cell current, so the electrode reaction gets reversed. So during charging, what happens is cadmium gets deposited on the anode and nickel oxide on the cathode. So what is the reaction is, that is exactly reversible to that of discharging reaction. So we can represent this reaction as cadmium hydroxide plus nickel hydroxide as charging reaction, whereas in the discharging we can represent in the reversible reaction. So this is about the construction and working of NiCad battery. So what are the advantages? Simply we can say the advantages are very high. They are going to have good load performance and allows recharging even at low temperatures. So lighter in weight, high current applications, smaller and lighter, like a dry cell it can be packed and sealed. It is the lowest cost battery in terms of cost per cycle. What is cycle means? One charging and discharging completed, we say it is a cycle. So it is the advantages of NiCad battery, but it has some disadvantage, that is it is expensive. And one more thing is cadmium even at the trace level is very toxic in nature. Due to this toxic nature, it may lead to cancers. So carcinogenic in nature. That is why NiCad batteries are of low interest nowadays, as the sustainable development is concerned or the environmental issues are concerned, we are making them less usage. So relatively low energy density, low capacity when compared to other secondary batteries, and has a relatively high self discharge and need to be charged after storage. So what is that is, whenever once we repack or open the package, it is going to be self discharged. That is why it has to be recharged if for every usage. So what are the uses? It is used in the emergency power applications and communication equipments, and we can use it in the electronic calculators, flash units, transistors and other battery powered small tools. So due to low temperature performance, it is widely used in aircraft and space satellites. This is about nickel cadmium battery. So other battery, very interesting, that every day our day has started with an alarm of mobile. What is this alarm of mobile? Is it is having some charging. That means the battery is under working condition. So what is the battery we are going to use in our mobile phones? Is lithium ion battery. It is a secondary battery. So what it have is, it does not contain lithium as itself as anode. What it is going to have is, it is going to have layers of porous carbon doped with lithium. As the name suggests, it is a lithium ion, and these lithium ions are responsible for charging and discharging. Generally in electrochemical reactions, electron transfer leads to oxidation and reduction, simultaneous redox reactions are being taking place. Whereas in the case of lithium ion battery, due to the layered structure, we are going to have intercalation and deintercalation of the lithium ions during the charging and discharging process. Based on that, we are going to have a spontaneous chemical reaction that is being taking place. Like this, we are going to have lithium ions that are responsible for the electrochemical reaction, whereas in all other batteries, the electrons that are transferred from the anode to cathode through the circuit are the active role. So, what it is going to have is a positive electrode consisting of lithium metal oxide, a negative electrode where we are going to have the layers of porous carbon. What is this porous carbon is? We are going to use graphite, as graphite is a conducting allotrope of the carbon, and we are going to have an electrolyte. What is this electrolyte? Is a polymer gel which acts as a separator too, which is, as you see, we have non-aqueous solvents here. We are not going to have aqueous solvents, we are going to have aprotic or non-aqueous solvents as the electrolyte, which are being dissolved in organic solvent. Why we need to dissolve in organic solvent is, if we dissolve in the water, what happens? Whether our batteries were under working condition, if you immerse it in water, no way it is possible. What we can say is, battery or the lithium ion battery is the heart of our mobile. So, we need to take care of our heart. So, it is being having an electrolyte that is being dissolved in organic solvent, and we are going to have dimethyl carbonate or diethyl carbonate as the binder or the separator. So, what happened is, we are going to have a construction where the positive electrode is typically made up of layers of chemical compound called lithium cobalt oxide, and the negative electrode is made from layers of porous carbon. That is why these batteries are called GIC batteries. What is this GIC batteries? Is graphite intercalated. That means, in the layers of graphite, we are going to have lithium ion that is being doped. So, both the electrodes are dipped in a polymer gel electrolyte and separated by a separator. So, which is a plastic and allows lithium ions to pass through the cell. That is why it is called lithium ion battery. Remember, it is lithium ion battery. That means, the lithium ions are more responsible for the charging and discharging process that is being taking place. Then what is charging? Is, during the charging, the lithium ions flow from positive electrode lithium cobalt oxide to negative electrode through electrolyte. So, electron flows from positive electrode to the negative electrode, and the electrons and Li plus ions combine at the negative electrode and deposit there as lithium. So, what happens is, lithium cobalt oxide at carbon, that is layered structure, we are going to have non-stoichiometric compound Li1 minus X COO2. What happens is, we are going to have Li plus ions that are being doped, so that we have a non-stoichiometric compound that is being formed during the charging as well as discharging reactions. Whereas, during the discharging, what happens? The reversibility of the reaction. What is this reversibility of the reaction is? The lithium ions that are being moved towards the other electrode are being moved back or reverted back. So, during discharging, the lithium ions flow back through the electrolyte from negative electrode to the positive electrode. So, what happens is, the electrons flows from negative electrode to positive electrode, and these lithium ions and the electrons combine to give a deposition of lithium at the cathode. So, Li1 minus X COO2, here we are going to use cobalt oxide. Why only cobalt oxide? We can also use lithium nickel oxide, lithium manganese oxide, whatever it is, we are going to have a layered structure. So, we are going to have the generation of energy during the discharging. As you know, if you have opened the battery performance of our battery in our mobile, if you have seen the graph, we are going to have a graph like this. Is it true? How it should be is, it should have a graph like this, it is a cycle. But what we are doing every day, whenever we woke up, we will keep it in the charging and we are going to check the notifications. Later we charge it to maximum and we will discharge it. We are going to support with the power bank sometimes, so that it is going to be in the critical condition. So, a battery should have a graph like this, and a critical lithium ion battery what we are using today of about 7500 mAh is going to have around 3600 cycles. It is called one cycle. 3600 cycles means assume how many days it should be. If you charge only once and completely discharge per day once, no doubt our mobile can work for around 10 years without any battery issue. But the problem today, maybe for 3 months we are going to exchange our mobile. Only one problem is charging issue. Why it is having is, we are having unjudicious utilization of mobile phones. We are not charging them properly, discharging them properly. So, this is a schematic representation of charging and discharging cycles that are happening in the lithium ion batteries. So, what are the advantages is, these lithium ion batteries are going to have high energy density. So, they can store a significant energy in small lightweight package and they can be used in mobile devices. Long cycle life, as we said, around 3600 cycles we are going to have, and lifespan around 10 years it has. Then fast charging and low maintenance. Today we have superbook charges or the turbo charges, so that we can charge a whole battery within 20 minutes, less than half an hour. We can also discharge like that only. And versatility, different models, that is why we have ultra slim mobiles today. Today the mobiles are slim, chargers are turbo. Whereas the disadvantages is safety hazards due to high reactivity. They are damaged or faulty cells overheat, catch fire, explode. High cost, no doubt, even though we are going to buy the mobiles. Aging with the degradation. So, after 500 to 1000 cycles, they are going to become wastage. So, environmental impact, no doubt, e-waste is the major issue today. What is this e-wastage? Electronic wastage in the form of mobile phones, batteries, especially batteries and printed circuit boards. So, they are going to cause the significant damage to the environment due to their toxic wastage. So, to summarize, a nickel cadmium battery is going to have nickel as cadmium as a anode, nickel as cathode, and KOH solution as the electrolyte, which can be rechargeable battery. Whereas lithium ion battery, which is most often used in the portable devices, is going to have layered structure, so that the working of the battery is due to the transfer of lithium ions into the layered structure through intercalation and deintercalation of lithium ions from anode to cathode and cathode to anode. Thank you.